Okay, so that brings us to trapezoids. Now, trapezoids are a little weird because unlike a parallelogram that's going to have a congruent chunk on each end that we simply rearrange to make a rectangle, or like a kite where I have halves that all match up, a trapezoid we can't guarantee is quite as pretty as that. Now, let's deal with one type of trapezoid where the top and the bottom are congruent, and I got one right angle, then I got this angly bit over here. So if I have that basic shape, the easiest way to do this is to break it into two pieces. Over here, I have a height, and the height is the same no matter where I'm at in the figure. And in this case, we'll call this base 1. This area here is nothing more than height times base 1. That's the rectangle. Now, we need to add something to that. We need to add this triangle to it. Well, let's see here. The height of this triangle is still the same, but now we have this like little base down here, little base, okay? Little base down here, and so what we can do is say, well, this area is 1/2 of the height times the little base. Okay, and so we have triangle plus rectangle equals trapezoid. There you go. Now, if I were to really kind of examine this, I could take this height out, so h comes out front, and so that's 1/2 of the little base plus a big base. But the thing about it is, if I wanted to, I could say this whole base down here is this little base plus base 1. So what I could really do is basically replace this and say, if I had these pieces together with a little half in here times a little height, I could find it piece by piece. But that is not the most efficient method. Okay, now the other problem is what happens when I come over here and I try to do the same thing with something that has triangles on both ends. Now, if these two are the same, that means these angles are the same, means this is an isosceles trapezoid. The good news here is I would have a triangle plus a rectangle plus another triangle, and that's all cool because these two triangles, congruent, 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 90 degrees, congruent, congruent, would go together, and in essence, if I took this over here, I could make a nice rectangle out of the rectangle bits, base 1 times height, base little times the height, and just add those two guys up, and that works out because they happen to match. But we get complicated again if I do this where I don't have the same on each end. So now I really do have a triangle, a rectangle, and another different triangle. So now this formula over here becomes 1/2 little base 1 times height plus base 2 times height plus another half of a base 3. Like this is getting just out of hand. So what we want to do is we want to find something that's a little bit easier to handle. And that is if I were to take and put my heights in a nice spot where I cut this bit in half. So when I have this shape right here, if I go halfway up and halfway up so that this is congruent and this is congruent, I already know from my mid segments that this is going to be parallel. If I draw my dotted lines right down these two dots, I make a nice pretty rectangle that is base times height. But what it means is I can't use this base and I can't use the big base. I got to use halfway in between. Well, how do I find halfway in between? Well, that's easy. I simply take one base, I add it to the other, and then cut it in half. If I do that, I find the average length from one end to the other, and all I got to do is multiply it by height. That's it. This is the formula for a trapezoid, which is the average of the two bases times the height. You can do them in separate bits, but separate bits get very confusing very fast and gets very complicated. If I simply find the average times the height, I'm all good. Again, by putting the average, that makes little bitty parts that this I could tip right up in here, this I could tip right up in here, and they would make a perfect rectangle, which is really nothing more than base times height. So find the average of the base times the height. That is your trapezoid formula.